All right, we'll talk about something called the first derivative test. And this is basically what we were just alluding to in our previous example. So it says if f prime x changes from positive to negative at c, c just represents a critical value or a critical number. So when we're doing our number line and you have a critical value at c, we're going from negative infinity to positive infinity. If it changes from positive to negative, so that means you found from negative infinity to c, the derivatives were positive, means the function's increasing, and then from c to infinity, say you found that the derivative had a negative value, so the slope of the tangent line would be negative, we know the function to be decreasing. If it goes from positive to negative at c, we have what you call a local max. And you can write this. It would be at the point c, comma, f at c. So you would take whatever this number is, and you would plug it back into the original equation to get the height of the function. In number 2, it's saying your number line goes like so. It goes from negative to positive, decreasing to increasing. Well, if the y values are coming down and then they go back up, they have to hit a low point. In this case, c represents a local minimum. And if you wanted to figure out the height of your local minimum, you would take that x value, whatever c happens to be. It could be a 2, it could be a negative 5, but you would plug it back into the original to get the height, and that would be the height of your minimum. And finally, the last one says, if it does not change, so if your number line looks like this, if it goes increasing on the left of c and then increasing on the right of c, or if it's decreasing on the left of c and decreasing on the right of c, that means you have no max or no min. Okay? That might mean your curve might be going like it's rising, and then there might be a little wiggle in the curve. You might have something like that. Or it might be a little more pronounced. You might have something like that. It's decreasing on the left and right, or increasing on the left and right. We'll explore those points in the next section. So positive to negative, local max, negative to positive, local min. Let's work through an example. Okay? The example is going to say, calculate the local maximum and minimum values of a given function. In order to do that, we need to find the intervals of increase and decrease like we did yesterday. And then we'll use the number line to determine if c is a max or a min. So let's move right to this one, example 2. Nope, you don't have it, so you'll have to copy it down. Please. Find the local maximum and minimum values of g at x equals x to the 4th minus 4x cubed minus 8x squared minus 1. And then they want me to use that information to make a sketch of g. It's just going to be a rough sketch, but we will have a pretty decent idea of what this curve looks like. And this curve is a 4th degree polynomial. So I think so far you guys have done linear functions in grade 10 quadratic functions or second degree, grade 11, you can expect to see degree 3, degree 4, or degree 5 in this course. So the function is g at x equals x to the fourth minus 4x cubed minus 8x squared minus 1. In order to do the max and mins, I need to do the intervals of increase and decrease. What's the first step in solving for the intervals of increase and decrease? Find the derivative. Okay? I am going to find the derivative of g at x, which I will call g prime x. What is the derivative of x to the fourth? Good. What is the derivative of negative 4x cubed? What is the derivative of negative 8x squared? And what is the derivative of a constant negative 1? Awesome. Next thing I'm going to do, I'm going to factor out a 4x. Good. 4x cubed divided by 4x leaves an x squared. Negative 12x squared divided by 4x minus 3x. And negative 16x divided by positive 4x. Wicked. I can factor further. So I took out a common factor of 4x. The trinomial here. I need two numbers that add to give negative 3 and multiply to give negative 4. X minus 4, x plus 1. Excellent. And then I need to find my critical values. To get your critical values, you set the derivative equal to 0, or you find the values of x that would make the derivative undefined. Not possible in this case because there is no denominator, or the denominator of this would just be 1. So all I need to do is replace the g prime x with a 0, and then solve. This is called the zero product principle. The only way I can multiply this by this by this, these three factors together, and get an answer of 0, is if one of them happens to be a 0. I don't know which one it is, so I have to take each factor. 4x equals 0, x minus 4 could equal 0, or x plus 1 could equal 0. And when I solve, what do I get here? X equals 0. What about here? What about here? So my critical values are my critical numbers. Negative 1, 0, and 4. Now I have to do the first derivative test. So next to my derivative, I'm going to draw what? A number line. And it's going to go from negative infinity to positive infinity on the right. What do I put on my number line? Negative 1, 0, and 4. How many intervals do I now have? 3 critical values gives me 4 intervals. One from negative infinity to negative 1, a second one from negative 1 to 0, a third one from 0 to 4, and a fourth one from 4 to infinity. Let's test these intervals. I can pick any number between negative infinity and negative 1. Suggestions? Negative 2, good. What am I testing? Where am I plugging the negative 2? In for x, but where? Into the factor derivative. You could use the original derivative, it wouldn't matter. It's just so much easier to use the factored form. Because really all I'm trying to determine is if the derivative is positive, that would mean the function's what? Increasing. Good, Callie. If the derivative's negative, that means the function's what? Decreasing. Wicked. So if I fill a negative 2 in for x, I'd have a negative 8. This bracket would be a negative 6. Negative 2 plus 1 would be a negative 1. 3 negatives multiplied together would give me a what? A negative. What does that mean? From negative infinity to negative 1, it's decreasing. The y values would be getting smaller. My curve would be going like this. Agreed? Between -1 and 0, what's a good test value? -0.5. You could use -0.9, -0.75, something between -1 and 0. Fill it in here. What's 4 times -0.5? It's a -2. -0.5 minus 4 is a -4.5. And this, -0.5 plus 1, it's a positive. A negative times a negative is a positive, times a positive is a positive. So that means between -1 and 0, it's going up. My y values are getting bigger. The function is increasing. Between 0 and 4, what do you want to use? 2, sure. 4 times 2 is 8. 2 minus 4 is -2. 2 plus 1 is +3. A positive times a negative times a positive gives you a negative. The function's coming back down. Agreed? And then from 4 to infinity, 5. 4 times 5 is 20. 5 minus 4 is 1. 5 plus 1 is 6. Positive times a positive is a positive, or positive times a positive times a positive is a positive. That means my function is increasing. So basically, if I were to join these sections, my curve would roughly looks like this. Arrow on this end, arrow on that end. Let's state the intervals of increase. I would say increasing on -1 to 0. That's an x value of -1 to an x value of 0. And where else? 4 to infinity. Decreasing on -infinity to -1. The negative sign, and the other interval with a negative sign above it is 0 to 4. Now let's refer to our notes on the last slide. And we're going to check -1, 0, and 4. What did we say on the last slide? If it goes from negative to positive at -1, what do you have there? Negative to positive. If I flip back, negative to positive gave me a what? A min. Positive to negative gives me a max. Okay? If it's positive, positive, or negative, negative, it's neither a max or a min. So what do we have at this situation right here? That's a local min. You can see it right here in the curve. Look, it hits a low point, and then it goes back up. What do we have at 0? It's going from positive to negative at 0. Local max. You can see it right here in the curve. And then, lastly, we have another what? Local min. And you can see it right here. Now, our job today is to figure out how low the curve goes when x equals -1, or how high the curve goes when x equals 0. And then again, how low the curve goes when x equals 4. If you want the function's height, where should I plug the x value -1, the x value 0, and the x value of 4 into? The original equation. Okay? So I am going to write down the original equation. It says g at x equals x to the 4th. Is that what I started with? And then what else? Minus 4x cubed?
And minus 4x cubed.
Minus 8x squared minus 1. Okay? So I am going to use this function, and I have to do 3 calculations. I need to figure out what the height is, when x equals -1, when x equals 0, and when x equals 4. So I will label this. This is my minimum. Local min at x equals -1. This can be my local max at x equals what? 0. Good. And this down here, I'll leave myself a little bit of space. This is another local minimum when x equals what? So all I'm going to do is I'm going to replace all of the x's with a -1 and figure out the height. And over here, I'm going to replace all of the x's with a 0. And I'll figure out the function's height. And in the last one, I'll replace them all with a 4. So 4 to the 4th minus 4 times 4 cubed minus 8 times 4 squared minus 1. So there's our setup. Give you a chance to get caught up. What's -1 to the power of 4? 1. It's -1 times -1 times -1 times -1. That's right. 4 negatives multiplied together give you a positive. 1 multiplied by itself 4 times is 1. -1 cubed would be a -1 times -4 would give me a -4. What about -1 squared? It would be a positive. That's why you get paid the big bucks, guys. What's this one going to be? A -1 squared? That'd be a 1 times -8, be a -8 minus 1. What do I get? Okay, 1 minus 1 is 0. 4 minus 8, -4. So as a point, I would know that when x is -1, y is -4. This is not an interval. It's not x to x. It's a coordinate. That's right. It's an ordered pair. That's x comma y. This is a pretty easy calculation. These are all just going to be zeros. That means my high point is actually at 0 comma -1, or my local maximum. I'll let you get that down. Give me the nod when you're ready to roll. She had 4. 4 to the 4th, that's 4, 16, 64, 256. This is going to be 4 cubed is 64 times -4, that's -256. So I'm back to square one, that's 0. 4 squared is 16 times 8 is 80 and 48. That'd be -128 minus 1. What do I get here? -129. Yikes. That's way down there, isn't it? 4 comma -129. Now, if I were to try and draw this, roughly? It's my y-axis. I'll do my x-axis. How did I make it so crazy like that, like way down? I'm going to negative 129, you bet. Okay, so I've got 1, 2, 3, 4, 5. And then negative 1, negative 2, negative 3, negative 4, negative 5. Now, I'm not even really going to label the y-axis because this is just a complete rough sketch. Okay? But let's put these points on. Where would negative 1, comma, negative 4 go? I'd go 1 to the left, and then down how many? Down 4 blocks, all right? So we'll say we go down, I'll just do something like this. Now, my scale's obviously not going to work out great here. That's why I didn't put a scale on the y-axis. I'm just trying to show you where the point may go, or where the point would go. Negative 1, comma, negative 4. What about the next point? Where's the max? That's right. So 0, x equals 0 would be here. Negative 1 would be like there somewhere. And then where's my other local min? Yeah, 1, 2, 3, 4. Now, obviously, I can't get down 129, so I'm just going to do like 4, and then I'll just drop it way down here, and we'll say, okay, that looks like 4, comma, negative 129. Okay? How do I join those points? How do I use this information right here to do that? Well, we kind of already did it up here. It's going to come down. It's decreasing until I hit negative 1, comma, negative 4. And then what does it do? It swings around and goes back up until I hit this point, which was 0, comma, negative 1. And then what happens from there? I drop it way down, and I got to go through the point 4, comma, 129. And when I get to that point, what does it do? It turns and goes back up forever. So this is what it would look like. Bear with me, okay? I'll full screen this. Tough to see, but I'm coming down. I'm going back up. I'm going down. And then I'm going to swing around and come back up. And that, my friends, is a rough sketch of the curve. But once we get making a detailed sketch, you'll see we'll add things like our x-intercepts that we started out with, our y-intercepts, which we started out with. We can discuss symmetry, intervals of increase and decrease, max mins. We're going to look at concavity and inflection points. And we'll put it all together and make a detailed sketch. So all you're really doing today is building off what you did yesterday. For the questions for homework, you'll still need to find the intervals of increase and decrease, but then use your number line to determine where the max and mins are. And remember, when you're looking for the height of the max or the height of the min, you got to go back and plug that into the original function, the y equals, or the f at x equals, or the g at x equals. Cool? Nice. Good job.